Okay, so in this video, we're going to follow on from our introduction to arithmetic sequences and look at some more scenarios that you could be applying your formula to. And just to recap from the last video, the formula for the general term of an arithmetic sequence is un equal to u1 plus n minus 1 multiplied by d. Okay, so let's take a look at some examples. Right, so we've got a sequence. You can see it there. We first of all have to show that this sequence is arithmetic. So just like in the last video, we're going to look at the difference between the terms. So we'll start with the second term, take away the first term. Well, that comes out at minus 4. If we then carry on with the third term, take away the second term, that is also minus 4. And I know this is a little repetitive, but we're going to write it out. And then we've got that last one there, 71 minus 75 equals minus 4. So we can say for sure we are arithmetic. That same common difference. Right, let's move on. Let's have a look at part B. Find the formula for its general term. So we can see very clearly that U1 is equal to 87. From part A, we can see the common difference is minus 4. So we're going to substitute those numbers into that general formula. So the general formula again is un equal to u1 plus n minus 1d. Let's pop those numbers in. So we'll have 87 plus n minus 1 multiplied by minus 4. Let's expand those brackets. So we're going to have a minus 4n and a positive 4. So my formula in its most simple form will be 91 minus 4n. Okay, there is our part B. Right, C, let's find the 40th term. Well, this means clearly that n is 40. We're going to put that into that formula we just found and see what happens. So we are going to have U40 is equal to 91 minus 4 times 40. Well, that is 91 minus 160. So U40 is equal to negative 69. Okay, finally, let's do part D. Well, part D says which term of the sequence is negative 297? Well, so that means we'll take that minus 297 and we'll set it equal to our formula we found, and we'll see what value of n is going to come out, and that will be the term number we're looking for. Okay, so first thing to do, well, maybe we could move the 4n to the left, and we can add the 297 to the right. So 4n is 91 plus 297. So that's going to mean that 4n is 388. We can now divide by 4. N is going to be 97. So which term of the sequence is negative 297? It is the 97th term. Okay, hopefully that made a bit of sense, and let's get into some slightly more challenging examples. So let's read this one very carefully and see what happens. So find k given that 3k plus 1, k and negative 3 are consecutive terms of an arithmetic sequence. So if these terms are consecutive, that's going to mean that there is the same difference, d, between each of the terms. So if I was to do the same trick as last time and to take the second term minus that first term, it's going to be the same as if I did negative 3 take away k, the third term take away the second term. Both of those are equal to the common difference, so therefore they're both equal to each other. And from there, what I can then do is I can solve that equation like any other. So let's expand those brackets and simplify. So k minus 3k minus 1 is equal to minus 3 minus k. And then maybe we can collect up the left-hand side and write minus 2k minus 1 equal to minus 3 minus k. Okay, now we're going to add the 2k to the right, and we'll add 3 to the left. So if I add 3 to the left, that minus 1 is going to become a positive 2. If I add if I add 2k to the right, I'm going to have k comes out equal to 2, and I have finished. Let's carry on, see if we can do one last question. So in this particular scenario, we've got to find the general term un. So we're looking for a formula here, right? But we know some stuff. We know that the third term u3 is 8, the eighth term is minus 17. So the best way of doing this, if we're going to find a general term, we're going to need to find u1 and d. So let's start by writing these in terms of u1 and d. So we know that 8 is going to be u1 plus 2d, and we know that negative 17 is going to be u1 plus 7d, and that is just swapping straight in from our formula there. Look, it's always one less than the term number amounts of d. So what we've got here is two simultaneous equations. Maybe we can solve these together, right? And maybe we can solve these. So let's rearrange them. Let's write them next to each other and see what happens. So we could take that first one and we could write it as minus u1 minus 2d equal to minus 8. I flipped the sign over there. Look, I've just times both sides by negative 1. And then I could also just keep the other one the same. u1 plus 7d equal to minus 17. Now, the reason I've done that is because now I can add those two together. So if I add them together, my u1s are going to cancel out, and I'm going to have that 5d is equal to negative 25. So from here, I can easily see that d is negative 5. So we're halfway there. We've found d. So now what I can do is I can pop that into one of these equations to help me solve. So maybe I'll pop it into this equation here. So 8 is equal to u1 minus 10, because now we know that d is negative 5. 2 times negative 5 is negative 10. So this is going to find that u1 is equal to 18 if I add 10 to both sides, and we are pretty much there. We found those two components. So all I need to do now is pop those into the general formula. And again, my general formula is un equal to u1 plus n minus 1d. So un in this case is equal to 18 plus n minus 1 times negative 5. If I simplify this, I can expand those brackets. I'm going to have minus 5n and a plus 5. This is going to leave me with the final answer of 23 minus 5n. Okay, so there is my general formula for this particular scenario. Okay, so this video was just to really go through a few of the applications of that formula. Some of the questions you might see are not straightforward, and you're going to have to use your own problem-solving ability to figure out what